Hey everyone, this is Mr. Becklin coming at you with learning target number 2, solutions to quadratic functions. Go ahead and pause the video and write that down. All right, so for learning target 2, solutions to quadratic functions, solutions are going to be one of the main topics throughout this entire unit with quadratic functions. We're going to be talking about different ways that you can find solutions, and today we're not going to really do anything with the solutions. We're just going to mainly identify them, so you might not really have an idea of what we're going to do with them, but this learning target is just to be able to identify. And as we move throughout this unit, you guys will learn what these solutions mean. Kind of like if you think about y-intercepts with linear functions or exponential functions even. Remember, we kind of looked at y-intercepts and we looked at the constant rate of change or the growth factor, and we kind of applied it to the situations and kind of understood what those numbers represented. So we'll be doing the same thing with solutions to quadratics. We'll be kind of understanding what they mean and how they could be helpful to us. But for today, we're not really going to do that. We're just going to kind of identify. So that's kind of our learning target for number 2. So, all right, let's go ahead and get started. So solutions are called the x-intercepts. There's a couple different ways that we can identify solutions. They're the x-intercepts, not y-intercepts. And they're also called roots, R-O-O-T-S, or zeros. 4 different ways to say it, but these could all be ways that we identify solutions of a quadratic function. All right, so let's first take a look at what a quadratic looks like on a graph. So a quadratic function makes kind of this U shape. We call this a parabola. One of my top 5 favorite words in math. This is called a parabola. And a parabola represents a quadratic function, and the solutions, remember we said, are the x-intercepts, are also called the zeros. We can see here that the parabola here, just kind of sketch this in. If you need to pause the video at any time to sketch these in. I know sometimes it's hard to listen, write down, make the graph all at once. It's a little bit tricky. All right, we can say this parabola or this quadratic function has 2 solutions. Those solutions would be at the coordinate pair -1, 0 and 3, 0. So those would be where the solutions fall, right? We can see they hit the x-axis here, and this quadratic also hits the x-axis here. So this would have 2 solutions. And another way that we can write these, sometimes we'll see it that way. Think about like the y-intercept. Sometimes we would do this. You could also just say x equals -1 and x equals 3. Because we know the y will always be what? 0, right? Any x-intercept, the y value will always be 0. Again, if you need to pause, go ahead and get that written in. All right. Now, going to another situation, there are times in a quadratic function we'll have only one solution. And you can maybe think about what that might look like. I'm actually going to make a parabola that's downward facing. We know that's still a function because it does pass the vertical line test, the VLT. And 1, 2, and I'll make that 4 just so we don't always have to see a 3 there. All right, so we would say this has one solution because it has one x-intercept. And that solution would be 4, 0. These are all going by 1s. Okay, or we would say x equals 4. All right, and another situation, could a quadratic function have no solutions? Sure it could. Maybe that's a situation where the quadratic or the parabola is not touching the x-axis. All right, so this would be no solution. And the reason there's no solutions because There's no x-intercept. Okay, so one important thing I kind of mentioned a little bit earlier in the notes is that x-intercepts always happen when y equals 0. That's kind of important for a few reasons. Some that we'll see later on in this unit. We'll kind of remember that when we do some other things later on with learning targets. But I guess for the time being, it can be very useful if we are looking at a table of values, right? And let's say, for instance, the table, we don't have a graph in front of us with a parabola, but we do see a table. And that table looks like this. We can see just by kind of inspection here that we know that x-intercepts happen when the y equals 0. And where do we see the y equals 0? We see it happen here. And we see it happen here. Okay, doesn't happen here. This would be actually the y-intercept, which we know from our notes previous is not a solution. The solutions are the x-intercept. So this actually has two solutions. And those two solutions would be at -3, 0, and -1, 0. Or we could say x equals -3 and x equals -1. Okay, so that is learning target 2, solutions to quadratic functions by looking at a graph or by looking at a table. Try to practice. See you guys.